Welcome to today's analysis. Today, we're diving into one of the most ambitious, borderline sci-fi projects happening on Earth right now. I mean, we've all heard of the Great Wall of China, right? But today, we are focusing on something totally different, the Great Green Wall. China is actually on this seemingly impossible mission to build a massive, living wall of trees just to stop their deserts from expanding. So how are they actually pulling this off? Let's break down the mind-blowing tech making it a reality. To really grasp why they're doing this, you have to understand the sheer scale of the threat. 32%. Just let that sink in for a second. A staggering 32% of China's total landmass has already been completely swallowed up and transformed into desert. It's a literal existential threat. China realized that, hey, if we don't destroy the desert is absolutely gonna destroy us. To put that into perspective, that equates to a geographic nightmare of 1.9 million square kilometers. That is how much land has already been lost to the sand. And this isn't just some empty wasteland problem either. It is actively hurting their civilization. We're talking massive, blinding sandstorms hitting major cities, devastated agriculture, and an annual economic blow of about 33.4 crore rupees. That's roughly $3.3 billion every single year. So the absolutely crucial question here is, how do you actually stop a desert? At first, China tried the simple manual approach. They sent out massive crews to dig holes, plant trees, water them, but it completely failed. Why? Because the grip of a young tree's roots in loose sand is just incredibly weak. These fierce desert sandstorms would roll through and simply uproot the newly planted saplings, or honestly, just bury them entirely. They clearly needed a radically different approach.
Which brings us to Section 1, the sand-eating machine.
To solve this nightmare, China deployed this mechanical marvel. It's officially known as the Zhumeng 301, but locals gave it a much cooler nickname, the Sand Eater. Now, it doesn't just plant a seed and cross its fingers. It executes a highly engineered three-step process. Step 1, before it even digs a single hole, it lays down a precise grid made out of bamboo and straw. This traps the sand and stops the wind from picking it up. Step 2, it injects a special binding liquid straight into the ground, literally chemically converting that loose sand into stable soil. And then, Step 3, it automatically selects a spot where the sand isn't too thin, digs down, and plants the seeds. The terrifying efficiency of this thing is what makes it work so well. The Sand Eater operates completely autonomously, seeding a whopping 2,000 acres of land in a single 24-hour period. Wherever this machine passes, it binds the earth so effectively that within about 6 months, that blowing sand is transformed into actual, stable soil. The sandstorms stop, and get this, green vegetation actually begins to take hold. Moving right along to Section 2, rebuilding the ecosystem. Now, as incredible as the Zhumeng 301 is, machines alone cannot sustain a living, breathing forest. And when it comes to ecological engineering, China has kind of learned the hard way that you can't just manipulate nature without some serious consequences. Take the infamous Four Pests campaign back in 1958. Millions of sparrows were systematically killed because people mistakenly thought they were eating crop yields. But actually, scratch that, the sparrows were eating the insects that destroyed the crops. So without natural predators, insect populations absolutely exploded, wiping out the harvest anyway. This triggered a devastating famine, and China eventually had to literally import birds from around the world just to fix the catastrophic imbalance they created. So to avoid repeating history, they aren't just relying on cold mechanics this time. They've paired a mechanical foundation with a biological catalyst. The Zhumeng 301 stabilizes the sand, sure, but to turn it into a genuine, self-sustaining forest, China imported millions of a very specific biological partner to finish the job: Rex rabbits. Now, you might be wondering, why Rex rabbits specifically? Well, it turns out these animals act as incredible biological engineers. First off, they dig deep tunnels, creating these large holes that act as natural traps for even more blowing sand. Second, their waste acts as a super powerful natural urea fertilizer, which provides essential nutrients for all those young plants. Third, just by moving around, they naturally disperse the seeds, really accelerating that transformation from sand to soil. And finally, the Rex breed was specifically chosen because they're tough enough to actually survive the incredibly harsh, extreme climates of the desert. All right, let's zoom out a bit for Section 3, India's expanding desert crisis. While China is aggressively pursuing this massive terraforming project,
It really serves as a stark lens to examine similar crises happening elsewhere, specifically India's own expanding desert crisis. And the contrast here is sharp. On one hand, China's Great Green Wall has this massive, highly visible on-the-ground execution. On the other hand, India has its own Green Wall project, which is intended to stop the expansion of the Thar Desert. However, based on the public data we currently have available, the project appears to be stalled. There's a heavy lack of public information regarding how many trees have actually been planted or what tangible progress has actually been made to stop the desert's expansion. And the stakes for ignoring this issue are just incredibly high. At its current rate of expansion, the Thar Desert could literally reach Delhi in just 5 to 10 years. That's not some abstract problem for future generations to deal with. The desert is actively creeping toward major population centers right now. So what's actually driving this rapid expansion? The sources point really clearly to human-driven causes. Rampant deforestation in the name of urban development is obviously a massive factor. But even more critical is the illegal mining happening right now in the Aravalli mountain range. Historically, these mountains acted as a natural physical barrier against the desert, but intense, continuous mining is systematically erasing entire series of these mountains. It's removing the very shield that kept the sand at bay. We are literally watching green forests be turned into barren lands right before our eyes. Now, hold on, you might be thinking, wait a minute, if we constantly need sand for construction everywhere, why don't we just mine the desert sand and get rid of the desert? It's a super common myth, but desert sand is fundamentally different. It's made up of extremely fine, wind-blown particles that are completely useless for modern concrete and construction. Believe me, if desert sand was profitable to build with, greedy contractors would have scraped the deserts entirely clean years ago. But because the sand is commercially useless, it's just left alone to expand. Which brings us to our final part, Section 4, A Changing Global Geography. What we're witnessing here is not just an isolated project happening in one or two countries. This is the beginning of a changing global geography. The sheer necessity of survival is forcing worldwide adaptation. Seeing the massive success of the Jumong 301, both Africa and Dubai have now actively begun adopting and importing China's sand-eating technology. They're deploying these exact same systems to fight back against their own encroaching deserts, attempting to turn arid sands back into green forests. And all of this leads to an absolutely fascinating projection from the source material. In 10 to 12 years, the entire global geography might flip. I mean, just think about what that actually means. If these massive terraforming projects succeed, the current maps we grew up studying in school, they'll be totally obsolete. Vast deserts could be transformed into lush, sprawling green forests. And conversely, areas we currently know as dense forests or protective mountain ranges, like the Aravallis, might become completely barren wastelands due to human exploitation. The Earth's ecosystems could quite literally trade places. Which leaves us with a final, really pressing question to think about. Will we step up, actively engineer forests, and reverse the ecological damage we've caused? Or are we just going to sit back and let the sand literally swallow our cities? The technology to fight back exists, but as we've seen today, it requires massive, coordinated action. It is a fascinating look at the absolute extremes of human engineering. Well, that wraps up our analysis for today. Thank you so much for joining me, and I'll catch you in the next breakdown.